All right, let's take a look at this clip from the Beastie Boys video "Sabotage." We've got this vintage police car traveling over the top of a hill at a high rate of speed, and in fact, as it goes over the top of the hill, you can see a little bit of daylight between the tires and the roads. That's got some implications for the free body diagram. So if you consider the car when it's on the flat surface here, nice flat surface, Mr. Harding. You're going to have FG down, and you're going to have F smoosh poosh up because the car is touching the road. And those forces are going to balance. So we'd be looking at something like this. But when the car is going over the top of a hill, if it's going fast enough that the wheels actually leave contact with the ground, well, there's no touching. If there's no touching, there's no smoosh poosh. I would just have this FG here, car, comma, earth. It's not touching anything else, so it's not interacting with it. So at that particular moment, at that particular point in time, that car is experiencing an unbalanced force equal to gravitation. Okay, so Fu equals Fg. And then if you think about this hill here, you got kind of like a radius of curvature, if you will. At that particular point in time, that gravitational force, so that Fu, it's pointing towards the center of the turn. Okay, so that's why we would call this a Fuke. It's an unbalanced force pointing towards the center. And as we saw from the lab analysis, our equation for Fuke can either be m v tan squared over r or m r squared omega. That's not right. Whoa! mr omega squared. All right. So I can just set this up over here then and say, okay, Fuke m v tan squared over r. Fg, that's just the mass times g times 10 newtons per kilogram. You see the mass shows up on both sides. I get v tan squared over r equals g. So the speed that I have to be going when I'm going over the top of the hill, the speed I have to be going when I go over the top of the hill then is going to be v tan equals the square root of g times r. So whatever the radius of the hill is, I take that times 10, square root of that. That's the speed I have to be going in order to catch a little bit of air when I go over the top of it. Okay, because that sets up this condition where the Fuke is equal to Fg. So that's just a quick little insight heading into the problem. Now, in the problem, the car is not leaving the road, so there'll still be a little bit of smoosh poosh, but you can think about how that would point, how that would affect the Fu. Similarly, when the car goes through a trough, you can see what happens here. Okay, the car kind of bottoms out. So if you think about the springs and the shock absorbers, they get compressed here. So think about what's happening as it goes through this depression, this trough, this bottom of a hill. What's going on there dynamically in order to result in an unbalanced force that points towards the center. All right, so good luck with the rest of that.